Well, thank you for inviting me. I'm going to talk about math. As you might have guessed, the title of my talk is the title of my latest book, Math Education in the U.S. And I make no apology for the shameless promotion of my book, of which I've also brought copies for sale at a low price, which I'll sign. And as some of you heard, I'm on a second career as a math teacher. And frequently teach 7th grade and 8th grade algebra in Cayucos. And many people think I got the short straw when they hear I'm teaching middle school, but I assure you it was my choice. I view middle school as the last chance attempt to fill in deficiencies students may have before they go into high school. And they're also incredible, and I really like working with that age, however frustrating it is on some days. Before I get into it, into what math education has evolved into in the U.S. Here's how I was inducted into the royal mess known as math education. And I was aware that something was off with math education when my wife and I met with our daughter's 2nd grade teacher, concerned that our daughter wasn't learning her addition and subtraction facts. And we were told not to worry because kids eventually get it. And then, given this good news, math topics from day to day aren't dependent on kids mastering a previous lesson. Now, it had been a while since I'd been in school. I thought, well, maybe things are different, so I was willing to suspend my disbelief, thinking, well, maybe there's better ways of doing things than when I was in school. But over the next few years, I learned about the reform approach to math, in which students discover and teachers facilitate, in which students must work cooperatively in groups, in which students must provide explanations for problems so easy they defy explanation, and in which consistently getting right answers to varied problems does not signify understanding. In short, it's an educational orientation that I and others like me, 1, did not believe in, and 2, found ourselves immersed in. Despite all this, and maybe even because of all this, I decided to teach math when I retired. So as you heard, I attended night classes at ed school and began writing articles about the state of math education in the U.S. My articles take on this groupthink of the education establishment in the reform, progressivist-dominated education schools. And with the adoption of the Common Core standards, which you may have heard about, it's been in the papers, by 42 states, the battle in the U.S. has become even more pronounced. So my talk today is an overview of the state of math education in the U.S. And I'll start off with a description of what's commonly referred to as traditionally taught math, and I'll talk about how it's traditionally mischaracterized. Next, I'll cover key features of the reform approach, and then how the Common Core standards fit into the scheme of things. I'll be focusing on primary grade or foundational math in my talk, not so much high school. I'll then conclude with guardedly optimistic statements, and I'll answer any questions that you have. So let's first look at what's called traditionally taught math. And traditionally taught math in general means teaching topics in a logical sequence, requiring the memorization of key facts and mastery of basic procedures, which are then built upon over time. The teaching method and classroom format presents information using a direct instruction approach in a whole class manner. And it usually takes the form of I demonstrate the technique, we now try it together, and you do the problems. I say general features because there are variations with some discovery learning inherent in it, Socratic type discussions, group work, and activities that build engagement. But traditional math is frequently mischaracterized as teaching that is inherently poor, stilted, dull, and artificial. Anyone challenging these, for instance, it's characterized as rote memorization, no understanding. The teacher lectures, it does all the talking. The students can do the math, but they don't know the math. It doesn't teach students critical thinking. And probably the most important, does not meet the demands of the 21st century is one of the tags I hear a lot. And anyone challenging these mischaracterizations by saying, well, I seem to do all right with it, is told, well, you're the exception. So this mischaracterization by denigrating past programs has been a strategy for those who wish to paint a contrasting picture of themselves and who may be seeking buy-in for new approaches. And this game has been played for a long time. In fact, you could probably track it all the way back to Euclid if you had the time, but I didn't have the time. So I didn't go back that far. I stopped at 1952 at the introduction of a 4th grade arithmetic textbook. Now, the authors of this 1952 textbook disparage previous approaches as teaching facts, skills, and procedures with no understanding. You can see that the old program, the new program. Old program had oral and written drill. The new one is drill for computational competence follows understanding. Now, this chart could just as well come from one of today's textbooks. I've looked in many textbooks that are out today, and I see the same comparison. And notice this facts and skills developed after understanding, because I'm going to come back to that later. Now, the people who wrote the math books from the 30s through the 60s were the reformers of their day, and they argued for the same thing as today's reformers. But their approach was different, and some, including me, have argued that it was effective. And one advantage of being as old as I am is that I can remember how math was taught. My era was the 50s and 60s. The elementary arithmetic books I had were written by some of these reformers, notably William A. Brownell, who was thought highly of even by today's reformers, including an education critic known as Alfie Kohn. So let's take a look. We had 2-digit and addition and subtraction explained in terms of pictures, words, and finally the algorithm itself. Learning how to carry, which is now called regrouping, came shortly after. There was a clear explanation of the conceptual underpinning, as well as the procedure. In fact, it would be pretty hard to teach this without explaining what place value is, since at every stage you have to reference it. And similarly, multiplication and division were also explained, and not as frequently mischaracterized, taught as times tables to be memorized with no connection or understanding of what multiplication or division meant. Now, one technique for adding, and I'm going to come back to this a little bit later, is known as the making tens method of addition. And here, and this is from my old textbook, here it shows how 9 plus 6 can be represented as, well, take 1 away from the other number, 9 plus 1, that gives me 10, and that leaves 5 with the other group, and that's easy. 10 plus 5 is 15, and that's known as making tens. It's a way to do mental math. Now, there were also strategies for 2-digit addition and multiplication, and these came from a 5th grade textbook, not mine. This one was from 1948. And the addition relies on place value. I don't know if you could read this, but it's a grocer. In fact, they used to call this grocery store math because they didn't have calculators in those days, and the grocer had to know how to do things fast in his head. And she's adding 27, 24, and 33 cents. And he says you add the 20, and 30 together, and then you add the 7, 4, and 3. That's 14. 7 and 14 are 84. It's just a quick way of doing math. And the addition relies on place value. The multiplication, a little too hard to read, but also relies on decomposing tens and something known as the distributive property. Now, there are many more examples, including explanations of fraction operations and why and how they work. It wasn't rote memorization, and topics were definitely connected and built upon. Could it have been better? Yes, of course. There could have been more challenging and interesting problems. But yesterday's students, when entering algebra, had a far superior grasp of the basics than many of today's students, and were well prepared for the next step. In fact, when I subbed in high school in algebra classes, it wasn't uncommon for me to see kids counting on their fingers or using calculators for things like 21 divided by 7. Now, there are two things I must mention very briefly before I turn to the reform progressivist math. And I think all of you remember, on October 4th, 1957, the Soviet Union launched Sputnik. And this event caused overall panic and the U.S. felt we needed to boost science and mathematics education or we would fall further behind the Soviet Union. The result was the typical time-honored solution that governments take when faced with a problem. They threw money at it. And a program known as the New Math was born. The curriculum was designed primarily by mathematicians and was fairly effective for high school topics, but for K to 6, it was based on a very formal set theory approach, too formal for many students and teachers who had to teach it. In fact, the Peanuts cartoon from that time, in the mid-60s, shows how it was viewed by the public. She's actually reading stuff that was in those books about sets, equivalent sets, and she ends up saying, all I want to know is how much is 2 plus 2, and that was the standing joke around that time. Now the New Math also incorporated aspects of discovery and was often billed as a whole new way to teach math, and in some ways set the stage for the next phase of reform math, which emerged in the 90s. New Math was deemed a failure in the early 70s, and math returned to a back-to-basics approach. Some say a bit too much, but students did improve in computational math. But in 1983, another key event took place. What with the US lagging economically behind other countries, and the Cold War still going on, panic set in again. And the National Commission on Excellence in Education published A Nation at Risk, warning that if we didn't get our act together educationally, we would fall behind. So this time an organization called the National Council of Teachers of Mathematics, or the NCTM, stepped up to the crisis, and in 1989 published a set of math standards, which were revised in 2000, to serve as guidance to our education system. NCTM was founded in 1920, and it's one of the largest private organizations concerned with math education. And the standards, curriculum and evaluation standards for school math, it was called, purported to put the country back on the math track. So with that, the next era in math education was ushered in. Following the time-honored tradition, disparaging everything that came before it, NCTM promoted its progressivist reform standards as a whole new way of teaching math. Now, NCTM's standards specified content that was to be taught, but the areas in NCTM standards that caught the attention of reformers and progressivists are shown here. It emphasized the use of calculators. The advent of the calculator made doing many so-called paper and pencil operations unnecessary. So these are direct quotes from the standards. Decreased attention to complex paper and pencil computations. Long division. We don't need to teach that so much anymore because we've got calculators to do it. Paper and pencil fraction computation. Who needs to do that? We've got calculators to do that. Rote memorization of rules. We don't want memorization. They don't really need to know their times tables. We don't really have to emphasize that as much. Now these quotes from the standards, some of which were removed and toned down in the later version, but these ideas have lived on. And these standards were not any kind of state requirement, but some states modeled their standards after NCTM's, and education schools promoted their ideas in the classes. And while traditional math teaching hasn't disappeared, the progressivist or reform math teaching practices over the past 25 or so years have been growing slowly and steadily. And what we've been seeing is more group work with teachers supposedly, or in which students supposedly teach each other, with the teacher facilitating as a guide on the side as students engage in discovery learning. So the I do, we do, you do technique that I talked about is considered rote memorization. Conceptual understanding now is given priority under an understanding first, procedure later approach. Understanding and procedure work in tandem, with understanding sometimes coming first, sometimes later, but under this approach, they had to understand first, then we can get into the algorithm. The teaching of standard algorithms was delayed. Students were required to do alternative approaches first. The standard algorithm first was viewed as eclipsing understanding of the procedures. So side dishes now became main dishes in the main courses, and students grew confused, and sometimes profoundly so. Problems are to be solved in more than one way. in the belief that doing so imparts and gives evidence of understanding. And inquiry-based and discovery approaches are thought to result in greater understanding. So as a result, you have students that are told, solve 15 divided by 3 in 6 ways. Do it as a multiplication problem. Yeah, 5 times 3 is 15. Do it by constructing equal groups of numbers. Use an array. Use an area model. Use the multiplication table. Write a word problem that goes with this. I've seen this. This is an assignment. You have students drawing pictures for much longer than necessary, serving as both a means to simultaneously understand and explain an otherwise simple procedure. The counting up method of calculation. You're probably all familiar with it because that's how we used to make change. But now they teach it as a method of subtracting by working backwards. Nothing wrong with that, but it's nice to have the standard algorithm first, as I'll get up to later. Tens and ones added first. That was like the cartoon with the grocer doing it mentally. But again, it's nice when you have the standard algorithm first, and then you can kind of, a lot of kids discover this on their own, ironically. Now, many of these are the same methods for addition and subtraction that are taught in traditional math. And as I've been saying, these alternative methods were taught after students had achieved mastery with the standard algorithms, not for weeks on end. And many of us have discovered these methods ourselves. So while the reformers or the progressivists all want to teach for understanding, they do so without defining what understanding is. So adding 56 plus 68 and being made to say, oh, that's 60 plus 60 instead of 6 plus 6 when they're carrying and adding the tens column defeats the purpose of the algorithm, which is to free up your working memory. It's the arithmetic equivalent of forcing a reader to keep his finger on the page, sounding out every word with no progression of reading skill. It amounts to little more than a rote understanding for procedures that unfortunately students probably can't perform for problems they can't solve. Which brings us to the holy grail of the Reform progressivist math, problem solving. The term problem solving has acquired its own meaning and usually entails discovery learning. Routine problems are viewed as mere exercises that involve applying algorithms, memorizing a solution method or a mnemonic device. The goal is for students to solve kinds of problems they've never seen before. So the progressive reformers strive for authentic problems that are application-based and engaging. The reformers who are adept at problem solving hold in disdain the standard problems and the process of providing initial worked examples and subsequent problems which are incrementally more difficult. What they now view as ineffective is probably what got them to where they are today, but they've forgotten that. So problem solving then is approached as a top-down process where students are given problems in entirely new contexts with little or no prior knowledge. And math problems that require outside of the box insight or inspiration are thought to impart understanding and produce a problem-solving mode of thought, independent of the mathematics and techniques that allow students to solve the problems. So in these top-down approaches, problems may be open-ended, or they may have multiple components, many of which students have yet to learn. So rather than mastering these things beforehand, they struggle to learn what is needed on a just-in-time basis. Now, this is like teaching someone to swim by throwing them in the deep end of the swimming pool and telling them to swim to the other side. And the teacher is standing on the side, yeah, now would be a great time to learn the breaststroke. And it gives instructions from the side of the pool. Now, while an expert swimmer may struggle to perfect his swim stroke, a novice struggles to keep from drowning in a struggle that doesn't teach them how to swim. Which brings me to the Common Core standards. These are grade-by-grade guidelines written for both math and English language arts. They're written by a group called Council of Chief State School Officers and the National Governors Association. And they've been adopted in 42 states and DC and replaced the previous state standards in math and ELA. The objective was that the entire country teach to the same goals. and they were published in 2010 with extremely little public input and amidst much controversy. Now, I would be remiss if I didn't mention that there are good things in these standards, requirements for fluency and mastery of standard algorithms. And my comments on Common Core focus on the early primary years, K-8 foundational standards, not on high school. I will say that there are some curricula, textbooks that interpret Common Core in sensible, effective ways. Singapore Math Series is one of them. Jump Math, which was developed in Canada but now has an alignment with the Common Core, is another. And there are also teachers who interpret Common Core sensibly and teach accordingly if they're allowed to. Now, having said that, from what I see happening, Common Core is the gasoline on the ideological fire of the reformers and progressivists, which has been burning slowly and steadily for the past 25 or so years. Now, I may be overdramatic here with this photo of the flames and so forth, but after all, they do call for demonstrated fluency in the math facts, nothing wrong with that, and they do call for learning the standard algorithms. Now, there's no mandate anywhere dictating that teachers must use discovery or student-centered approaches, and it even says so on the Common Core website. So why is it then that many Common Core inspired assignments shown on television or on the internet or in the newspapers bear the reform progressivist imprints? Student-centered and discovery-driven assignments, group-based and real-life relevant, touted as fostering critical thinking and told this is what Common Core requires. Now, one clue as to why this happens, I don't know if you remember these guys, it's from Monty Python, comes from the language embedded in the standards, the subtle nudge, nudge, wink, wink, know what I mean references that are picked up by the reformers and progressivists. So, for example, the words explain and understand are the prime examples of this, which are embedded in many of the standards. Explain the reasoning used, that's first grade. Explain why addition and subtraction strategies work using place values and the properties of operation, that's second grade. Understand the relationship between numbers and quantities, kindergarten. Understand a fraction as a number on the number line, third grade. Now, these are key signals to the reformers, and given the progressive reform background of some of the people on the math standards team who wrote these standards, I don't believe this was entirely coincidental. The three lead writers were Phil Darrow, Bill McCallum, and Jason Zimba. Phil has a degree in English literature and has been active for years in promoting reform math. Bill McCallum is a math professor who teaches at University of Arizona, and he's been sympathetic with the reform approach. Jason Zimba, who has a doctorate in physics and taught at Bennington College, is less sympathetic to the reform math ideas than the other two, but public statements he has made indicate he's not averse to such ideas. The rest of the writing team, as well as the team that reviewed and commented on the standards, were largely reform-oriented, but some disagreed. Jim Milgram, a retired math professor from Stanford who was on the review committee, refused to sign off on the entire package. Now, the wink-winks of understand and explain feed into two key components of Common Core. First is a set of 8 standards called Standards of Mathematical Practice, or SMPs, and 2, the standard algorithms. So let me talk about the SMPs first. The SMPs are 8 practices that supposedly embody the work habits of mathematicians and were defined largely by non-mathematicians. And 3, I don't have this on the screen, but most real mathematicians believe are platitudes. But let's take a look at them. And they're not so bad, because taken at face value, they're seemingly benign. For example, there's nothing wrong with the first point. Make sense of problem solving and persevere in solving them. Who wouldn't want this? But the words problem solving are a signal for convoluted and tedious real-world problems and just-in-time learning. The SMPs are thought to teach habits of mind, often outside of the context of the math courses from which they would arise naturally. So getting students to think algebraically outside of an algebra course, for example. Now, in the world of reform math, habits arising from content knowledge has been off the table for years. But even some mathematicians are swayed by the wouldn't it be nice if students could do this quality of such daydreams. And it's not to say that the SMPs have to be interpreted this way, but the nudges and the winks have reformers, progressives stating that Common Core in general and the SMPs require inquiry activities and collaborative group work, students solving problems in more than one way, and most importantly, for explaining their answers, requiring kids in the early grades, 4th grade, to write out paragraphs of how they solved a problem. Here's an example of a 7th grade explanation. And the assumption is if students can't explain their reasoning in writing or otherwise, then students lack understanding. If you can't explain it, you don't know it. That's the theme that's going through here. But students in K to 6, even in 7 and 8, are novices. They lack skill in articulating ideas, and such explanations often have little mathematical value. It often amounts to students engaging in the exercise of guessing or learning what the teacher wants to hear, and kids are pretty good at that. More rote understanding via rote explaining. So these kids have got a lot of splaining to do. Which brings me to how Common Core handles the standard algorithm. The reformers believe that teaching standard algorithms first eclipses students' understanding of why the procedure works. So the first mention of a standard algorithm is in the 4th grade for multi-digit addition and subtraction. That's the one where you line up the ones, line up the tens, and you regroup or carry. A delay also happens in the 5th grade for multiplication, 2-digit multiplication, and long division, which is delayed until 6th grade. Prior to that, the standards refer to drawing strategies based on place value. So grade 1, add within 100. Grade 2 and 3 fluently add and subtract within 100,000, but it isn't until grade 4 that you use the standard method. But according to 2 of the lead writers of the standards, Jason Zimba and Bill McCallum, the standard algorithm can be taught earlier than the year in which they appear. This isn't made big news. Zimba, in fact, even wrote it in an article. Recommends teaching the standard algorithm for, the 2-digit addition, teaching it in the 1st grade. And he says it, Common Core requires the standard algorithms, additional algorithms aren't named, and they aren't required. It's a pretty strong statement. But the built-in delays are a very big nudge, nudge, wink, wink to the reformers, which may be why, despite Zimba's statement, the standard algorithms are delayed in the belief students are better able to conceptualize the why instead of the how in performing operations and explain what it is that they're doing. So Zimba's word apparently isn't getting out. So teachers have been sending home notes like these. This is really taken from actual notes. Do not teach your child the standard algorithm for computations until he or she has learned it in school. And that's why you see these cartoons. But Mom, that's not how we were taught it. Well, that's the way I know it. But that's not what the teacher wants us to do. You've got this arguments going on all the time. Instead of the standard algorithm, we use the area and partial product strategy for multiplication. Well, I don't want to close on such a sour note. So as promised, here are some guardedly optimistic statements and closing thoughts. The Common Core standards may be a blessing in disguise. The reform methods and philosophy are getting more notice and protest than ever before. With the increased attention and pressure, perhaps this philosophy, the progressivist philosophy, will lose its grip and math education will be approached more effectively. So here is what I and many others would like to see become part of the next version of a whole new way to teach math. Whether understanding or procedure comes first ought to be driven by the subject matter and student need, not by educational ideology. Prior learning and knowledge is the greatest determinant of what children can learn, regardless of their physical age. Curricula should be both mathematically coherent and logically sequenced for learning from novice to expert. Discovery should not be conflated with teaching understanding as if they're one and the same. And mistakes should not be clung to just because of the time spent making them. So with that, that's my talk, and I'm open for questions if you have any. Glad to answer any questions you may have.